In today's program, we have to teach us ways we can solve some questions in integral calculus. So we just decided to pick up a question, okay, in integral calculus and do the solving. Now, there are many rules of what? Integration. I said that integration has many rules. Okay, so given this particular question, integral 2x plus 1 divided by 2x, the x. That is, we are asked to integrate 2x plus 1 over 2x. Okay? How do we do it? Are we going to use integration by parts? Okay? Or integration by substitution? Okay? Or any other rule of what? Integration. Okay, by mere looking, I don't think that actually integration by substitution will work, or even by parts. So, I solved this. On your own, you can even think what rule will work. So now, check this out, okay, how I'm going to manipulate this integral equation, okay, or integral expression. All right, now I say solution by Makasi Chinedu. All right. Now, let me integrate this now, okay? Let me rewrite this function, okay? Actually, the normal integral function, okay, which is integral 2x plus 1 divided by 2x dx is equal to integral. All right. From the numerator, let us factor out 1. Okay, 1 is a common factor there because 1 multiply each of the terms is still the terms. Okay, so let us factor out 1 from the numerator, okay, of the original expression. We have what? 1. All right. Okay. We have 2 as the divisor. All right. So, okay, let me have times multiply by this. Okay. All right. This fraction. Okay, x. Then the dividend is still 2x. 2x plus what? 1. All right. Then dx. Okay. So at this point, I actually rewrite the expression in another form. They are still the same thing, okay? The original expression of integral 2x plus 1 over 2x dx is equal to integral 1 over 2 times 2x plus 1 over what? X dx, okay? Knowing that from the right-hand side of this equation that 1 multiplying the dividend, okay, is still that dividend, okay, 2x plus 1. Then from the divisor, 2 times x is also what? 2x. So nothing has what? Been altered. They are still the same thing. Okay, so I work with the right-hand side, okay, of this equation. So now, let me factor out, okay, let me take out, okay, 1 over 2 out of the integral insignia, that is. Let me take out the half, okay, 1 over 2 out of the integral symbol. Now say, take out 1 over 2, okay, take out the 1 over 2 out of the integral symbol. Take out 1 over 2, okay, let me say take 1 over 2 out of the integral symbol. All right, so doing that, I have half integral 1, half integral, that is half integral of the expression the divisor here is over x. Okay, we say 2x plus 4, right? Okay, dx. All right. So again, at this point, we can actually divide each of the terms, okay, in the, okay, let me say this again. We can actually create two fractions, okay. No, the terms inside the integral symbol involves just one fraction, but we can, create a two fractional terms, okay. How do we do that? We divide each of the dividends, okay, terms, okay, by what? X. All right, so doing that, we have 1 over 2 integral. We have 1 over 2 integral. 1 over 2 integral 2x over what? X, okay? So we have 2x over x, okay? So plus, again, it's 1 over x, okay, dx, all right? So we know that this ds actually is common to the two of them, okay? So I have my dx, all right? So, but you know that this x here, we have to what? Cancel it, solve. So we cancel out the x, okay? We cancel out what? The x. Okay, which makes the equation to be reduced to what? Half, that is 1 over 2 integral 1 over 2 integral 2 plus the fraction 1 over x, okay? The fraction 1 over x dx. Okay, so, all right, so dx. All right. So now, let me distribute the x and the integral symbol, okay, across the terms, okay, across the whole number and the fractional term, okay. So, doing that, I'll have to multiply the half by all of them, okay. So I have half, that's 1 over 2 times integral, okay, integral 2 dx plus integral 1 over x plus integral 1 over x dx. Okay, so at this juncture, it is so evident, so apparent that actually we can employ this sum or difference rule of what in integration, okay? But in this case, we have to employ only the sum what rule of what integration. So doing that now, we have half, okay, that is 1 over 2. 1 over 2 times, okay, when we integrate 2, like one of the rules of what integrations is that the integral of a constant is that constant times the variable, in question, okay? Integral of a constant is that constant times the variable in question, all right? Here, the variable here is what? X. So integral 2, okay, the x will give us what? 2x, okay? That is multiplying the constant by the variable. Again, we differentiate this 1 over x. Actually, we note that 1 over x, okay, 1 over x, okay, is equal to x inverse is equal to s inverse. That is x to the power what? -1, okay? So suppose this x now is a positive number. If we are to integrate it, okay, we will have it what to be what? the natural log of what? X, okay? All right, and again, suppose this X is a negative number, we will have to what? Place the absolute bar, okay, in the natural log. Why? Because we don't have the log of what? A negative number. Rather, we only have log of what? Positive what? Numbers. Okay. So now we have 1/2 times integral 2 the x gives me what? 2x, right? Okay. So let me put this in brackets, okay, for ease of understanding. Okay. Again, if I'm to integrate 1/x, okay, which is x inverse, all right, I'll have to have okay, let me put it in bar, all right, in the absolute bar, okay. Lane, there's natural log, okay, of x, all right, that is lane x, okay, or you can say log x base e, okay, where e is a natural number, all right. Then we close the bracket, all right. So I've actually integrated, okay, the function or each of the functions, okay, using sum rule. Now, let us distribute, okay, the half, okay, across the terms, okay. So distributing the half, I will have 1/2 multiplied by 2x, okay, 1/2 times 2x, okay, again plus 1/2 times the length of what? X, all right, which is placed in absolute bar, okay. All right, so doing that we have, okay, half, that is 1/2 ln x, sorry, okay, 1/2 ln x, okay. All right, so at this juncture we know that the 2 we cancel out, okay. So we cancel out the words 2 goes out, strikes off, okay. So that is it, okay. All right, and we're left with x times 1. X times 1 gives me what? X times 1 is x, so we have x plus ln, okay, ln x plus, okay, let me do something, okay, x plus ln x over 2, let's say ln x, okay. All right, so please, absolute bar, we go from the divisor just to, all right. So this actually is the solution, okay? That integral of 2x plus 1 all over 2x dx is equal to x plus natural log of what? X over what? 2. That is our answer, okay? So whenever a question is being given to you, try to what? Reason before you can be able to do the mathematical manipulation. Some people may try to what? Apply the subtraction rule of what? Integration, because we have some fractions, okay, from the original question. But really, it may not really work. All right? So we will have to what? Brainstorm first of all before we deal with the question. Thank you so much for watching. Thank you for watching. Please subscribe to my YouTube channel. Thank you so much for watching. Oh. All right. Okay. Subscribe to my YouTube channel. Okay. Makassis Academy. I'm responsible for any typographical error or verbal mistake found in this video, please. Okay. Thank you so much.